Your alarm clock erupts. It's chilly, so you crank up the thermostat before making breakfast. You flip on the news to see what the weather will be like outside. It's not even 8 a.m., and you've already encountered a series of measurements. And the rest of your day will be guided by an inescapable string of numbers that define your world. In your car, at the office, on the road, and even on the bathroom floor. Nearly everywhere you go and everything you do depends on measurements. They're what lifted us from the Stone Age into civilization. To ensure that we get the right amount of fruit, gas, or postage, the National Institute of Standards and Technology, or NIST, defines all of these measurements and more.
We are responsible for what's known as realization of the primary units of measurement. We are charged with the research and the dissemination of the basic units by which we all measure our lives.
NIST was born out of tragedies like the Great Baltimore Fire of 1904, which wouldn't have been such a disaster if all the United States were operating under a standardized set of measurements.
During that fire, 1,500 buildings burnt to the ground. The Baltimore Fire Department called for help, and crews came from Washington, D.C. and New York City. But when they arrived in Baltimore City, they found that their hose couplings did not match the couplings of Baltimore fire hydrants. And so they were not able to help, and the importance of standards for things like hose couplings and fire hydrant fixtures became very, very apparent.
For the 7 base units of measurement, length, mass, time, electrical current, temperature, moles, or the number of elemental bodies in a substance, and luminous intensity. The standards are all here. NIST maintains the meter, our critical length standard. In 1791, the French Academy of Sciences divided the longitude from the North Pole to the equator, through Paris, into 10 million parts. Each fraction represented 1 meter. In 1889, the International Bureau of Weights and Measures created a meter bar made of a platinum iridium alloy to act as the standard. This is the United States' actual meter bar, the one that every length measurement was traced to for over 90 years. The meter bar proved impractical. The metal alloy is worth over $100,000, but it's still susceptible to wear, and therefore change. So in 1983, the world's measurement community agreed to redefine the meter as the distance light travels in a vacuum in 1,299,792,458th of a second. But hold on. Why does America care so much about a unit of measurement it doesn't readily use?
It's been estimated, in fact, that U.S. manufacturers, about 75% of them are totally metric.
For Americans, the continued use of the inch-pound system is merely a historical holdover.
As colonists from Great Britain, we didn't have our own measurement system, so we brought what we were familiar with when we came to the United States.
The U.S. customary system is mathematically impractical. 12 inches are in a foot, 3 feet are in a yard, and 1,760 yards are in a mile. Conversely, the base unit of length in the metric system is a meter, and its other units are expressed in multiples of 10. A kilometer is 1,000 meters. Regardless of whether you're working with metric or the U.S. customary system, your measurement is only as accurate as the instrument being used. The standard length measurement regulated by NIST is the basis for how companies like Stanley Tools create professional and consumer distance measuring devices. At its manufacturing facility in New Britain, Connecticut, workers roll out more than 10 million tape measures a year.
Stanley was founded in 1843, really around hardware products, which are hinges and the like, by Frederick T. Stanley and his brother. The old adage, measure twice and cut once, has been with us forever. And if you're inaccurate in what you do, then every other part of that project or that development will be incorrect.
Each step in the manufacturing process is essential to the final product's ability to take an accurate length measurement.
We're at the slitter, which is the beginning of our tape roll operation. This is where we take wideband material and we slit it into whatever size our customer requires. Each tape roll has a blade, and it also has a spring that's about 2/3 of the length of a blade. So what we have here is a tool that's actually slitting 7 pieces of 1-inch wide tape roll material.
These massive steel wheels will become individual tape measures. To make the tool easier for one person to use, the tape measure has to have good standout.
Standout is how far can this blade measure something with one person, essentially. How long will it stand out on its own? This product will stand out 11 feet, which is an industry best.
To achieve a desirable level of standout, the steel blades for the spring and the tape rule must be heat treated and tempered after they're slit.
What we're doing here is we're hardening the material in this furnace. It's coming up to like 1800 degrees. Then we're quenching it with water.
This process also gives the tape rule its curve. After the blades have their bath, machines apply the signature yellow paint to the entire length of the tape roll. Then workers haul them off to printing.
These are 2 bands that we print our tape rolls with. One band is black that we put graduations on. That's the important part of printing. The second band is the red band, that are the graphics.
The so-called laser interferometer, utilized by Stanley Tools to ensure the accuracy of each of its tape measures, is traceable to the NIST standardized meter. If the graduations on the rule are off, Stanley can compress or stretch the bands to adjust the print.
After we've printed a coil, we take one blade, bring it into this gauge, and this gauge, at pre-described increments, measures from 4 inches to the end of the blade. If this sample is accurate, then all the tape rolls from the previous sample are also accurate. And this is our in-process check to ensure the accuracy of everything that we manufacture. The device actually measures to the center of every single graduation. As an example, any particular rule setup has variances along the length, and this machine will find 5 discrete points and check for tolerance at that point.